Today we're doing some radicals review. Now this is something that we worked on in algebra when we're talking about radicals. We're talking about square roots. And we're going to talk about simplifying radicals and dealing with them today because the next chapter is going to deal a lot with radicals, and so we should be familiar with these concepts again. Most important term that you have when you deal with radicals is perfect square, and remember that numbers that are perfect squares are any number that has an integer square root. Integer meaning, a nice number, no fractions, no decimals. The numbers that are perfect squares, then, you take the square root, nice answer. Any other number that's a non-perfect square has that irrational number when you take the square root, because it'll be that decimal that never ends or never repeats. So let's get a list of perfect squares here. Starting with the number 1 is technically a perfect square because the square root of 1 is 1, and 4 is a perfect square because its square root is 2. Then 9 is a perfect square, its square root is 3. 4 squared is 16. 5 squared is 25. 36, perfect square because the square root is 6. 49, perfect square because its square root is 7. 8 squared is 64. 9 squared is 81. 100 is the next perfect square. Its square root is 10. 121 squared is 11. 144 is 12 squared. And 169 has a square root of 13. And obviously this list goes on, but these are the ones that you should be very familiar with and kind of know in the back of your head. First thing that we're going to be doing today is working with simplifying radicals, simplifying square roots. And the way you're going to do that is you break the number inside the square root into perfect square factors, meaning find a perfect square number that multiplies into these numbers inside the radicals. So you're looking for numbers like 4, 9, 16, the perfect squares that we just listed. You're looking for one of these numbers to multiply into the number inside the radical. Because if they do, you can at least take that number, that perfect square out of there. So, looking for these numbers to multiply into the numbers in the square root, be a factor of. So, can you think of a perfect square factor of 80? Meaning, which of these perfect squares would multiply to give you 80? Well, okay, definitely 4 times 20 would work, and 4 is a perfect square. However, I might look for a bigger square root, bigger perfect square, because I know that 20 would also be 4 times 5. So that would involve 2 steps. There's got to be a bigger perfect square, and since there were 2 4s, 16 should go into 80. And if you're not sure, you go on the calculator and you start dividing 80 by some of these perfect square numbers. 80 does divide by 16. 80 is the same as 16 times 5. So here's factors of 80 where 16 is a perfect square. Now why did I do that? Because I can take the perfect square of 16 out of here. The square root of 16 is 4. And left in the square root is just that 5. Now this is a simplified radical because I took out as much as I could from inside the square root. 5 does not have any perfect square factors, so I can't go any further. But I took out that 16, square root of 16 was 4. And the number 50 here, you're looking for which of these perfect squares, what perfect square would multiply into 50. And hopefully you're thinking, well, 50 is the same as 25 times 2. So instead of square root of 50, I can write square root of 25 times 2. Why would I do that? Because I can take the square root of 25 out of here. The square root of 25 is 5. So that's what's outside the square root now. I took that out. Inside the square root is just that 2. And I can't go any further, so there's my simplified radical. Next one, I have square root of 320, which, big number here. I'm trying to find probably a larger one of these square roots that goes into 320. I'm actually wondering if 64 works. Oh, I got lucky. I divided 320 by 64 and got 5. So 320 is 64 times 5. Sometimes it takes a little bit to find those perfect square factors. Eventually you will. Now why would I do that? Because I can take the square root of 64. I know the square root of 64 is 8. And then inside the square root is just that 5, which does not break down any further. Okay? So practicing simplifying these square roots. Square root of 24. What perfect square numbers multiplies into 24? And I think it's just 4. 24 is 6 times 4, right? Now why would I do that? Because I know the square root of 4 is a perfect square. The square root of 4 is 2. Inside the square root is still that 6. And there's my simplified radical. So first thing you should be able to do is simplify radicals by breaking down into perfect square factors and taking out those perfect squares. You should also be able to multiply radicals today. Now with multiplying radicals, if there are numbers outside the square root, multiply those numbers together and it'll stay outside the square root. And if there's numbers inside the square root, multiply those together, they will stay in the square root. And then simplify, because it's possible that the new number you get in the square root will break down as we saw in the previous examples. So for example here I have 3 square root of 6 times square root of 2. The only number outside the square root is that 3, so that stays outside. In the square root though, since I had 6 and 2 in the square roots being multiplied, 6 times 2 is 12. So that's my new number inside the square root. And now like I said here, simplify further if you can, because 12 has a perfect square factor. I can rewrite 12 with a perfect square factor of 4. 4 times 3 is 12. And now I can simplify further by taking out the square root of 4. Now the square root of 4 is 2. That goes out in front. What are we doing with everything in here? These are all being multiplied. So I'm going to end up doing 2 times 3 outside the square root. So now getting 6 out there, square root of just the number 3 remains. And that's as far as I can go. In this next example, 4 square root of 6 times 5 square root of 8. Actually, notice there's 2 numbers outside the square root, 4 and 5, so I will multiply 4 times 5 and get 20 outside the square root. In the square root, I have 6 times 8. So the new number in the square root is 48, right? 6 times 8. And then you see, does 48 break down at all? Does 48 have a perfect square factor? And it does. You can start dividing by different perfect squares. If you just saw 4 right away, 48 does divide by 4. It would be 4 times 12. But 12 has another perfect square factor, so I should have a bigger perfect square than just 4. 48 actually divides by 16. And that's the one we're looking for. 48 is 16 times 3. And I do that so I can take out this perfect square of 16. The square root of 16 is 4. I multiply with the numbers now outside. 4 times 20 is 80. Inside the square root, just my 3. So multiplying radicals and simplifying them. You should also be able to square radicals today. Sorry about these crazy square roots. I have to try to put those bars and they move over, so I apologize for that. But squaring radicals, make sure that you are kind of, in a sense, distributing. I mean, it's not really distributing, but in a sense, you're squaring everything in the parentheses. Okay. So if you have a set of parentheses and you're squaring, I'm squaring 2, I'm squaring square root of 7 as well. And remember that squaring undoes square root. Squaring and square root are inverse operations. They undo each other, and that'll kind of help you along. So let's say I'm doing 2 squared of 7, that whole thing squared. Well, really I'm doing 2 squared, which is 4, right? 2 times 2 is 4, times whatever square root of 7 squared is. Well, think about that. Square root of 7 squared. Square root and square root undo each other. Okay, they cancel each other out. Square root of 7 squared is 7. So 2 I really did have to square, it's 4. Square root of 7 squared just undid or canceled out the square root. So really 4 times 7, or 28. And let's try that one more time. If it was 4 squared of 3, that whole thing is squared, then 4 is squared, and 4 squared, 4 times 4 is 16, times whatever square root of 3 squared is. But again, square root and square just sort of cancel out, which is just 3. Or you can think of it as square root of 3 times square root of 3 is square root of 9, and that's 3. But either way, square root and square cancel. So now it's 16 times 3, which is 48. And you notice when you're squaring and you had a square root in there, your answer does not have square root because, again, of this inverse operation thing. They undo each other. Another thing that you should be able to do today is divide with radicals. Now, there's actually a problem here. We say dividing radicals, but we never want a square root in the denominator in the bottom of a fraction. So this is a big no-no, having square root of 2 in the bottom or square root of 3 in the bottom of that fraction. And to get rid of it, you're going to multiply by that radical on top and bottom of the fraction. The reason why I'm going to multiply on top and bottom, so you're saying like square root of 2, this is the naughty radical, so I'm going to multiply by square root of 2 on top and bottom. The reason why that's okay, what's anything over itself? This is like I'm multiplying by 1. And it's really okay to multiply by 1 because that's the only number that you can multiply by and not change what you had. So I multiply by square root of 2 on top and bottom. It's a fair thing to do. And I do that because the square root in the bottom will go away. In the numerator, I have 3 times square root of 2. And I write it just like that. But on bottom, think about it. I have square root of 2 times another square root of 2. And it's like square root of 2 squared, which is just 2. Or it's like square root of 4, which is 2. So by doing this, I get rid of square root in the bottom. It's okay to have square root in the top of a fraction, but this would be the correct way to write that. No more square root in the denominator. We're good to go. Okay. Looking at this example, there'll be one more step involved. You notice I cannot leave the answer this way. There's a square root of 3 in the denominator. That's a big no-no. So get rid of it by multiplying by that naughty square root of 3 on top and bottom. Again, this is like multiplying by 1, which is why it's an okay thing to do. In the numerator, then multiplying across, I get 6 square root of 3. On bottom, this is why I did this step, because square root of 3 times square root of 3 is just 3. Right? Square root of 3 squared basically cancels out just 3, or it's square root of 9, which is 3. But this goes one step further, actually. Look at the numbers themselves. I have 6 divided by 3. Well, 6 divided by 3 is 2, and still square root of 3. So look to simplify further if you can. So now we talked about simplifying radicals, multiplying radicals, squaring radicals, and dividing radicals. Be sure you can do all of these steps today on the homework.